Yeah.
Right. Let me check. If I make co-host to others, they can also. So now you lost the control, or you can.
Yeah, I can again. I'm
You
good.
Now I
can.
can now I can unmute myself. Thank you. Yeah.
Yes, yes. So let me make everybody a co-host. Otherwise, I don't know who's one to who's going to speak, right? Balaji, it's good for you as well. Okay. Thank you very much. Perfect. All right. So let's proceed ahead with this. So implementing regularization and normalization in Keras, right? Batch normalization, mini batch, and all those things will be seen. So what I mentioned is drop connect, if you remember. So if you can say something like that. Last time I have discussed the theoretical concept and the conceptual framework of drop connect versus dropouts, right? If you remember, right? You
Uh,
can't hear any. Yeah,
yeah, I remember.
perfect. Can you just give us the hints like what exactly it is used for? Drop connect, how it is different from dropout? Mathematically, I explained those who, I mean, I don't know, Balaji and Vinesh, you were there in the previous session, but just in case if you forward. So, what dropout and drop connect are deviated upon is very thin line of a difference. At drop connect, we try to zero down uh, the connections between the neurons by selecting a particular, masking layer. Versus dropout is basically where we actually mask the entire neuron itself. So, Dinesh and Balaji, can you quickly confirm so that we can go ahead without discussing the previous agenda? I mean, I have discussed with that mathematically on an Excel
Yes,
file that
yes. Yeah. Last time I was there, Ravi. Yeah, I'm good.
Yeah, I'm good as well, Ravi. Yeah.
thanks, Dinesh and Balaji. So now what happens is input normalization is we are going to see now. Input normalization means neurons and their normalization, like making them standardized. And there is another technique by which we can further normalize them, which is batch-wise normalization. So it can happen pre and post activation. For example, there is activation function which is involved in a layer. Before that, we can normalize, and even after that, we can normalize the another layer. So it is layer-wise normalization and versus a batch like the entire sample. So let's say the batches of your iterations, sorry, the samples can also be normalized. So we can see how we can shift from input normalization to batch normalization. Do we improve our accuracy or not? Because end goal is what? To optimize in such a way that errors are the least and my accuracies are the maximum. And lastly, convergence happens at training and testing. That's the end goal, right? Nothing, rest of the things I'm already agnostic. I don't care about anything. It's just mathematical computation which should give me the better results. And there are multiple ways to do the same thing. Layer normalization is also there where you can find a layer. Okay, this is the layer number 1, 2, 3, what, and I need to normalize at that layer. So likewise, you can have input. You can control the inputs with the neurons. You can control the batch where you control the batches of samples, and you can control normalization for layers, hidden layer 1, 2, 3, input layer, blah, blah, blah. Not to normalize the end layer because end layer is the outcome, which could be regressive output or it could be classification output, right? So there we need to get the actuals. And what is the what happens when we normalize any data? Why do we normalize? Maybe you
It
can remember scikit-learn kind of discussions earlier we had.
it will make a bell curve.
Yeah, it will help us align to that normal distribution, and that normal distribution in turn help us to fit all the logics rules which are fit for any regression or a classification issues, right? Okay, let me admit two more people. Aditya has joined us. Okay, just in case if I'm in middle of session, if you find anybody, please add. Okay. So Sasi and let's say Aditya, what we have started with is we had a wonderful demonstration today by Silva. He has done a great job in terms of Streamlit application created for his end-to-end, LLM ops engine, which basically I think it's more of a RAG framework, which he worked out on retrieval and workaround. Second thing is we started with the session goals. The session goals were already being discussed last time, if you all remember. Sasi and need to check with you also, Sasi and Aditya. We discussed about drop connect versus dropout, very clearly the difference between them. And now we would be heading towards input normalization, batch normalizations, pre-post activation before that and after that, and layer normalizations. Layer normalization means we have multiple layers, hidden layers. At each layer, we can attain the normalization. Reason is to standardize the data so that scaling is good. We can make it less, the kind of calculations with less outliers and with less number of uh, computations requirements, right? Otherwise, what happens is if suppose one variable comes with hundreds units, I mean the units in thousands, one comes in millions, will be taking its own time. So we standardize them, normalize them to access in a better way so that we can work out on normal distribution based assumptions. Coming back to the next thing is dropout. How do we work out on dropout, drop connects and all these things in Keras? So very quickly, what I'll do is I'll take it directly to the exercise where we are first of all preventing overfitting with random neuron draw. So that we discussed mathematically. This time we'll see algorithmically, like how exactly on our algorithm we can attach this dense with dropout. Next thing I'm going to demonstrate is how can we launch drop connect. Okay, mathematically seen, but how we can program it, that's what we're going to work out. How do we apply a normalization for a given neuron or input, and how do we apply it for layer-wise normalization, and then the comparisons, right, amongst these. So let me discuss this, then we go to the exercise. In dropout, drop connect, batch norm, layer norm, what do we do is we deal with overfitting. Drop connect help us to deal with sparse connections, which basically could be like a random network. So that helps us to identify the significant networks or significant neurons out of the n number of layers. And batch norm and layer norm help us to attain faster convergence because of standardized and scaled kind of units. Majorly when we use dropout is leveraged when we are using deep neural networks or convolution neural networks. Drop connect is basically used when we customize a pre-built model and fine tune it further. We can create our own custom models on that. CNNs again are a part of, batch norm is again a part of CNNs, and layer norm especially is dealt when we are dealing with NLP, natural language processing, or RNNs, because there we need to have significant layers and their weightages. So I'll discuss that also mathematically how it works. So regulation in short, you can see it reduces overfitting while normalization improves stability and convergence speed by making the data standardized. So what is the activity we are going to have today? So build a CNN on CIFAR 10, that is image classification data, and adding a dropout plus batch norm, then creating a drop connect and layer norm, and then comparing the results all together from the kind of exercises, right? Let's have it. All right, here we go. So we have the major library. I hope you can see my screen. I have shifted, right? It's now on Colab.
Yes, sir.
Perfect, thanks. So we have CIFAR 10. That's again, let me tell you, apart from CIFAR, you can also have this YOLO data sets. Most of the times people used to have that. And some more data sets I'll discuss. Let's say, let's have that as well. No. And for GenAI perspective, if you want to build your own SLM, I will not recommend a large language model, obviously. That requires its own infrastructure and all. So accordingly, we can plan. What I want to give you a dump is on common crawl. All right. So parallelly, I'm working on two things. One, you can definitely work on super dataset YOLO for images. And if you're doing the same practice for large datasets to work out and build a small language model, use a GPT model to, or let's say distill GPT, which is open source, to get it and fine tune it, you can always use a common call data. So discussed long time back how much data it is having. It's having almost now 50 billion more pages are being added. So earlier it was 250, now it's 300 billion pages spanning 18 years. Free and open corpus. The only thing is identify right set of data and try to get that from the API itself. Okay, perfect. Where we have, so if we go ahead now, we have, let me give it from. So here we can do is, so Kaggle is one source. You can have one more sources, Google research. Okay. And Google research and dataset. Okay. I don't know how many of you are using data search via Google. So there also you'll find certain observations. Let's say image data for right. So there is something known as B2 find multimodal ground truth datasets for abdominal medical imaging image registration data. So from healthcare to multiple aspects, you will get the same image data also, where you can test your small language model. Why I'm discussing parallelly two things, because one, we are working on the traditional and let's say the more relevant pre-built models, which we have discussed, CNNs and all. And at the same time, we need to see from where the data is coming for my small language model if I build it upon. So you have image, video, everything coming from Google dataset search. So you can also get the latest one. You can have multimodal satellite imagery. You can have multi-care open source clinical datasets. Whatever you want, you can search it here. You'll have definitely as per your domain. Okay. Okay. Given a dump on where exactly you can further R&D, right now let me go back to the exercise. In this example, what we are doing is we are taking the CIFAR 10 dataset. Department of Computer Science, University of Toronto has that dataset enlisted. 60,000 such images are there with 32 cross 32 kind of color images in 10 classes. So the classes are airplane, automobile, bird, cat, deer, dog, blah, 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 like that. Okay. Again, not very much focused on use case, more focused on how do we fine tune the layers. So please don't get carried away with that. You can definitely have any other data set coming from these different types of categories. Most importantly, it would be like coming from Google dataset search. Okay, by the way, any questions on data collections, especially on images side? Like
It
from your
shows
domain?
that random images which are classified in a way for our training and development purpose.
Okay. What you can do is, I don't know what is the quantum of images you want, but the best way is you can also generate these images these days, right? So you can use a GenAI to even generate a data set. So if it's a good project where you don't see the available images, what you can do is you can prompt and get that image accordingly, and then try to build it on the top of it. Because I don't know what is the exact use case. Can you let me know with an example which use case you're talking about? Random or what?
Actually, I mean, airplane, automobile, bird, cat, deer. I mean, what each
So,
category, which how it relate my analysis, what I'm going to achieve out of these
okay,
combinations.
I tell you. So what happens is, by this exercise, you should understand one thing, that how we are processing image. It could be anything. It could be car. It could be architecture. It could be Eiffel Tower. It could be anything, any structure. The thing is, how do we build a model on the top of any images? And how do we train those layers? That's why I said let's be agnostic to the use case. You can get the particular image data as per your images or on medical side or satellite side, wherever you want. The logic remains the same. What is the
Okay.
logic? Yeah, the logic is in what pixels the image is coming in, how we are processing the images, and on the top of it, the CNN is implemented. So CNN is the core goal here. And if you remember it correctly, when I discussed you CNN variants, right? You should be clear that how many layers, what kind of innovations are happening, and what kind of model I should pick up for beginning of the CNN part. So asking,
Okay, sir.
yeah, got it. So let's see what kind of okay infra is going to be there. What is this? Once again, just to give a brief, when we are talking about any CNN architecture, let me take something from here. So what we are going to do is we have something as an input. Those inputs are nothing else but you can see the pixels which are coming in, the processed data of what we call it, the processed data of your images. How to process it? OpenCV I mentioned. You can process multiple ways. In multiple ways, you can standardize, you can blur, do the black and white, grayscale, and all these things. Get those images. On the top of images, we work on a 7 by 7, 3 by 3, whatever kind of convolution metrics you want to work upon. And that basically that convolves. And convolution is what? Shifting or migrating the matrix of 3 by 3 or 7 cross 7 on the input. And then adding padding and all, right? Max pooling is getting the maximum value out of the particular pool, right? Average pooling is you're taking the average of that particular matrix. 7 cross 7, taking the maximum when you're multiplying with each and everything. Uh, Global average pooling is taking the maximum average from the entire data records. That is done in the end, right? Global average pooling is basically done in the end. What is basically is important is this layer, which is going to be something in the form of a vector. That could be one single vector that is fully connected layer. Okay. Do I need to discuss again CNN or we are good? I had a long time back a discussion on end-to-end on CNN. Please confirm. How mathematically work out, right? So I shown you a matrix. On the matrix, I try to show you the mathematical workarounds on calculating how we are multiplying the vector, the matrix with respect to the input and getting the total, then dividing by the total number of observations. Likewise, we go on and on and on, and then try to generate the fully connected layer. Anybody require that input again? Because I think we spend good time on that part. But do let me know, please. I don't want to work on assumption, right?
I
Anybody?
agree with you, Reddy, but for our poor memory and recollect
Okay,
on today's session, I would request you little touch base on that will help us. Yeah.
okay. Sure, sure, sure. So give me 1 second. What I can do is let me because if I again type and all that would take time. So let me find some handy tool so that you can CNN calculations and let's something is there directly. Mhm. There is very one good article, very good article one. The thing which I'm looking for, but I don't know whether I have copyright on that, so I can't show you. Let me see the cheat sheet. Otherwise, I'll take it in Excel if I don't see the maths. Oh, it's given here. This way you're good, right? Okay. So let's have the CNN cheat sheet. So what is happening is if you are seeing the okay, let me use my give me a second. Let me bring the pen tab. Okay, just a second. Okay. You can hear me loud and clear. Once again, a quick check, sanity check.
Yes, sir.
Okay. So if you see now, what I'm going to annotate is, let's say there's an image, right? The input image is there. This particular bear would have different sections. Like if you see, I can take any matrix 3 cross 3, 5 cross 5, 7 cross 7, like that. Okay. Anything which you can take. Now, basis that, if you see this image, uh, which is basically a bear, you can divide into multiple parts. Okay. What happens is, let's say this is one cell. One cell is equals to, let's say, 7 cross 7 kind of a matrix, which I'm going to take. Okay. What will happen there? This is a colored image. So by default, what happens is this is identified as red, green, and blue. Three channels are there, right? So this is going to be very hectic thing, right? Hectic thing in the sense because computations will be more, and it's always advised to first of all convert that into a grayscale. So let's have a grayscale bear image, and there are multiple images which we need to identify. Say there's another image of a tiger or a lion. Now same thing will happen to that particular, another image also, what I'm going to mention here. So this frame or a convolution aspect or a filter is attached and to be worked out on the top of each and every cell of this particular, image. So what do we do there? We actually try to see the matrix. Say this matrix is having, okay, 3 cross 3 kind of a input, and I have something as 2 cross 2 input, which is like this. I'll try to multiply these values, okay, respectively. Any sample reference you can take. The frame could be any sample you can take from this image. Basis that this multiple components, okay, of this particular, image will be multiplied. Then the average sum would be taken up for every cell, and then average would be taken up. So that we have done last time. I'll again showcase that. If that is being done, what happens is we try to reduce the size of this image. So this is the image size reduced, further reduce it until unless you get a fully connected layer. And what is a fully connected layer? Where you get one single vector, which basically has very few inputs, or let's say few neurons, right? So there's only 1, 2, 3, 4, 5 pointers. And same is happening for a tiger also. So let's say tiger is also having that same thing. Now what you do is compare these scores, whatever the values are there. These are all statistical values, right? So let's say one value is 0.55, one value would be 0.42, one value would be 0.19, 0.25, and 0.17. I'm not taking minus values because I have already implemented ReLU, right? In images, we try to deal with ReLU so that we avoid the minus values. Otherwise, it will be very difficult calculations, right? Images are very much cumbersome. And the another images like 0.55, 0.32, 0.18, 0.55, 0.45. Now take this particular sum. So let's say it is 5, 4, 9, and 10 to 12 and 13. So again, it goes to what? Something like, say, 1.30. This comes as, let's say, 2.10. Take that ratio. If it is kind of a matching for these two images, we'll see that, okay, if it is 100% same, if this particular total versus this total is almost 100%, now you get a clarity that, okay, images are completely matched, correct? If this is 50% matching, so we'll say that, okay, there is a 50% match between these two images, which means that the kind of values we are getting out of this simplification of process is based on the intensities and the posture and whatever the items are there. The multiple components of images are there, which we discussed. So basis that 0 to 255 kind of scoring, we can get the intensities, right? Light versus dark. And then we say, okay, this piece, for example, if I have X versus another X, if I take this portion okay, of this matrix. If I put it over there, tell me, any mathematical computation will be different or not? Will it be same or different? Suppose there is X, there is another X image. Okay, I take this portion of this matrix, I take this portion of this matrix, and this is divided into 3 cross 3. No batteries to be charged. Will I be getting different scores?
Same score.
Same score, right? When I stride it, what is stride is shifting this from here to there. Take to the right. Will I get a different score? Similarly, will I get a different score here versus the another one? Like that, you can imagine we are moving that filter up and down, uh, left and right to get those particular values and then create a final vector. So how it looks like, this is image 1, this is image 2, how much percentage is match? That's a very simple mathematics.
So the fully connected, the final output layer, it should be a one dimension always.
Yeah, always.
Okay.
You can calculate from here also, that's not a problem. But the thing is, you can get confused, right? So let's say there could be multiple parts of image, right? And then you don't know actually on what part it is actually, making sense. So you're taking everything out of that intensity and summarizing that in one single layer. So it is simplification at the same time, good calculation to show exact match.
So here convolutions are that's basically a layer which keep on we are adding when we are getting a output in a considerable way. Then that many number of layers we are adding. That's what I'm
Yeah,
understand, right?
convolution is hidden layer only, nothing else.
Okay, okay.
Convolution means like we are adding this. Earlier, what we used to do is we try to have another formula. What was that? That was just only weight into x plus bias. Here, nothing works like that. It is just taking a filter of yours, random filter of your selection. I should say choice, and then scroll it up and down. That's it. And
Okay.
mathematics is multiplication will happen, right? All these units will be multiplied with selected piece of that image. Then you apply global pooling, maximum pooling, average pooling, and taking the centralized value. So let's say if I multiply all this things, take the average and put that in the center. So only one value for this 3 cross 3. Take another, move it right side, take another value, put it somewhere in the another center. Okay, centrally, and then try to fill it. It's very difficult to imagine even, you know.
So the first rule, I mean, all the images which has to be 360-degree, which has to be left, right, up, down, all the
Yeah, yeah,
ways, that need to be processed. Based on that,
seriously.
it will get repeated again and again. Okay.
Yeah, can you see that this striding? This process is striding on every, this 3 cross 3 is striding over every cell. So first cell, let it come. Yeah, first 3 by 3, second 3 by 3, like that. 1, 2, 3, 3 strides. 1, 2, 3, 3 strides. And this larger size becomes smaller. And long time back, I think I shared one mathematic sheet also, right? How we can see end to end.
Okay, sir.
I'll get that for you guys. Okay, no worries. So going forward, what you can see now is, okay, what is a convolution layer? So it is using a filter. Where is my annotation? That performs convolution operations as it is scanning. It is kind of a scanning only, right? Move on from left to right. If okay, one layer is missing, you can add a padding also as per your choice, right? Padding is what? 0, 0, 0. Adding zeros so that we can manage that strides.
So the intention of padding is making a square.
Yeah. Otherwise, sometimes it could be like non-symmetric, right?
Okay, sir.
Yep. All right. So this is the movement here. Its hyperparameters include filter size. What is filter size? Selecting a particular filter of your choice is filter size. This is 3 cross 3. In our example, we have taken, sorry, 7 cross 7. This is also you can select randomly. Nothing, but yeah, take it something on a 3x3 so that, it's a small filter. You try with maximum outputs. 7x7, I don't know how many times it will be fit. And one more thing, strides, right? What is stride? Stride is nothing else, shifting this left stride, right stride, top stride, bottom stride, like that. We'll see.
So the bigger the size of the filter, which costs more execution in that case.
Yeah, exactly.
Okay.
And why it will be bigger? Because the image is very highly dimension. Having a high dimension. So you remember that dot per inches, right? High DPI means highly digital image. The dot per inches is actually going to be pixel work. Now see the mathematics of pooling. One more time, let me show you first of all what happened. So while I was riding, what happened is there was this, what is this? 1, 2, 3, 4, 5, 6. Okay. 2, 3, 4, 5, 6, 6x6. So let's say there is a 6x6 kind of a data. Pardon me, I'm not good in drawing, so very bad. There's 3, 3, 3. Okay. Now suppose there was X. Okay. There was something written as X. You can imagine that this is written somewhere. Okay. So I have some values like 100% intensity. And just assuming images will not be like that. Just see that. What happens is I don't have any values in the remaining cells. Like there is no intensity at all or darker sides. It's reflecting. Otherwise, it's absorbing. So let's say I put something as 0, 0, assuming that I select a matrix 3x3. You remember that 1, 1 is what? X, right? So there's 1, 1, 1, 1, and 1, 1, 1. Elsewhere, it's 0. Okay. So now if you see, I have uh, exactly the same arm of this X. Somehow I got that filter itself. So 1, 0, 0, 0, 1, 0, 0, 0, 1. When I multiply this, what will happen is 1, 1 is a 1, 0, 0, 0, 0, 0, 1, 1, 0 again, 0 into 0 is 0, where it is 0 and 1. I get the same output, right? Now I take the sum of it. So 3 divided by total number of observations, say 9. So 3 by 9 I'm getting. Okay, that is 1/3. Let's say 0.33 something. Okay, now this 0.33 will be my center value. So this 6 by 6, okay, this 3 by 3 is removed. What is there? We have 0.33 only. So this arm is now having 0.33. Now let's move to the right side. So let's say this is 0.25. This is 0.15. This is 0.35. You got it? Moved left to right, top to bottom. And then instead of 6 by 6, I get 4 by 4. How many of you got it?
Yes, sir.
Okay. So my size is removed, right? I mean, from that 6 row, it is 4 by 4. Again, you can now, this very simple image, right? So you can now make it easily 0.33 a vector, right? 0.25, 0.32, 0.15. Do the same for another image, and let's say it has the same score. So it is 1 divided by 1, which is 100%. No problem at all, right? This is what is the basic mathematics. Nothing complex. Shall I remove it?
So
All
probably
good?
when it again based on the comparison of which is a smaller image, with that
Yeah.
it will try to compare it with the bigger image, right?
Right. See, and what happens is we'll select one filter only. You can try multiple. You can choose any random filter of any sort of major image. So it is just how much you can bring that part into that small filter, which is a good representative for your image. That is going to work out. It's a art actually. I mean, I don't see it something as very strictly mathematics here. It's basically how do you identify those patterns, right? How do you identify that stride? Sometimes luck also. So now let me show you what is pooling. So pooling layer is nothing. What is the pooling layer is nothing else but it's downsampling operation typically applied after a convolution layer, which does spatial invariance. In particular, maximum and average pooling are special kinds of pooling where maximum and average values are taken. So, for example, if I got certain values, from those values also you can select should I take maximum value or an average value and global average. Global average means what? From the entire cell, let's say of XYZ size, let me have a global average. Then another filter, sorry, another image or let's say layer, because there are three channels. If it's a colored image, right? And if it's like black and white grayscale, two channels. So likewise, this is going to work out on every layer of that image. And image doesn't look like to be very small like this 6 cross 6, right? What we have is I think 124 cross 120. Okay. So each pooling operation selects maximum value of each current view, that is max, averages. Each pooling operation averages the value of current view. So your max will be taken from where? From these cells, maximum. Again, you can see it is not 3 cross 3, it is 2 cross 2. Can you see that? Okay. Likewise, you can play with it. Then fully connected is what? It is a flattened input where each input is connected to all the neurons. Remove that. Okay. So on the basis of this, the object is classified as whether it is going to be XYZ item. And then on the top of it is fully connected. If you want, you can further play with more hidden layers. I mean, let's not get into that here. And let's see the filter, how filter looks like. So filter cannot be two-dimensional, right? It can be multi-dimensional also. So you can choose filter of this size, that size, whatever size, right? So which means that if I have a f by f 2 by 2 filter, it is applied on how many channels? Let's say three channels. Channel is what? It's going to be RGB. So you can see that it is very difficult, right? On every channel, this filter will move. Strat is what? Moving left to right, top to down. So if it's a 3 cross 3, you can see this is moving 3. Then how the next 3 is taken, you can either take from the second portion or you can even move that. I mean, how that stride is defined, that I'll show you. What is padding? Padding is just adding one more layer to the boundaries. Okay. Then tuning hyperparameter, I'll come back to this. Let's not get into that complexity, otherwise you will not remember those formulae. What I would like to showcase now is, yeah, which particular major aspects are taken up in terms of activation functions. ReLU is taken before classification. You can implement ReLU. So ReLU is going to be rectified linear unit where you take either maximum of 0 or x item, whatever. So minus is avoided. Leaky ReLU, you can take a gradient of that. Leaky ReLU will not help you to get, sorry, will not result into vanishing of the gradient where all the maximum values are 0 or 1. So 0 will slow your process, and there could be exponentially elevated leaky ReLU. So that is another thing. Okay. So traditional CNN is what? Which you are going to see. There is a teddy bear, and a traditional CNN classifies a picture, predicts probability. But if you have a YOLO as a pre-built, or CNN as a pre-built, what you can do is you can identify not only an object, but also predict the probability of an object and its location as well. So you can have a bounding box. And then you can have multiple such things, right? You can identify teddy bear, you can have multiple items on the same thing. So that way the frame is added. So traffic, like kind of, cameras, they're enabled with these kind of images, bounding boxes for every object, number plate, an object, the type of that object, the speed can be identified, multiple things on the camera. All right, so many things, but yeah, let me come back to this once we complete the exercise. So let's have the CIPA 10 datasets where we have 10 different classes of.
The URL, could you please share that URL that you have showcased for us just before?
Oh, yes. This one, right?
Yes, sir.
Where are we? Here are the. Okay. Sorry for the background. If any, it's festive season, so I can't control, the society. And because of network, I have to definitely choose my drawing room. So what happens here? Oh, sorry. This is already being selected, so shared. This is already being discussed. This I have discussed. This you can do in your free time. I'll discuss that once again when we deal with GenAI. This also let me close. YOLO I'll discuss separate. Coming back to this. So TensorFlow, Keras, all these things, input layer obviously, dropout function, yes. We need to see dropout, drop connect kind of things. Batch normalization, layer normalization, then dense to add layers. Convolution 2D, maximum pooling 2D, max pooling is used. You can have global average as well. And flattening for the final fully connected layer, right? These are the major classes or the functions from the given set of library. Okay. What you're going to do is we are going to have CIFAR 10 datasets, which is divided into X train, Y train, X test, Y test. So, okay, I have mentioned this in the last exercise. Why do we divide this by score by 255? Anybody? Anyone? I have discussed that, right? What is 255? See, we are getting the value of every pixel, sorry, for every image as per the intensity from 0 to 255, right? So we'll get 175, 129, blah, blah, blah. So instead of that, what we do is if we divide by 255 itself, the entire values comes in the range from 0 to 1 kind of, right? So just to normalize that. So images getting dumped. reshaping them, so that we can deal with them into a flattened object directly. 32 cross 32 cross 3. What we discussed, we had 124 versus 124, correct? Earlier. Now building a baseline model. Let's see how we are defining model now. Obviously, Keras, and in that package, what we are doing is we are using sequential model, not a functional one. Input has a shape of 3072 kind of a score. That is the defined from the. Oh, sorry, guys, just a second. This also need to be tuned. All right. So I've discussed that how do we decide the inputs and all. This is again 2 to the power of x kind of items, right? And we have 10 as an output, our neuron. Why? Because we have 10 different classes of objects. So outcome remain or output remains same, input remains same, input, and between that, let's have dense layers with 512 versus 256 kind of neurons in different layers. And here we are using the metrics as accuracy, loss as categorical cross entropy, because I cannot use dichotomy here with respect to two classes. It is multicotonomous, so it is going to be categorical cross entropy. And optimizer is Adam optimizer out of multiple assets. And use dot fit to train the data on training data set with epochs as 5, batch size 128, randomly chosen, nothing specific about it. Validation data is created, it tests as X test and Y test. And callback is happening for plot loss, whereas they TensorFlow, so that we get the plot over there with respect to the object. First epoch having 9391 kind of operations, you can see. Accuracies and losses are getting tuned with respect to the time. It's decreasing, accuracy increasing, loss is decreasing. And likewise, once the epoch 5 are being set, we'll be generating the plot, which is accuracy versus loss between training and validation. Without doing any much fine tuning, there is no convergence happening. At the level of accuracy, you can see that training is validation data set is having better accuracy than training, so it is underfit. Once I see the loss, you can see that obviously the loss is more for training and less for validation. It's underfit altogether. There's 4 epoch running out of 5. Once it is completed, I'll go ahead. Meanwhile, let me explain what is happening is, now I'm building a function, build dropout batch norm model. Batch normalization is done. At the same time, dropout is also attached. So batch normalization is what? Attached on. So the batch normalization is whatever data 128 batches we are running on the top of it, then we attach that particular normalization. So what is normalization? Getting the x minus average divided by standard deviation kind of a score for whatever the input we are having. Why do we do that? To fasten the process of convergence and to have standard data. Nothing specific more than that. Dropout is impacting entire neurons to zero down. I mean, 50% neurons are to be zero down. So that masking is done. I already discussed in the previous session what is dropout versus a drop connect. So maybe if you want, you can again go to the previous session. So dropout is 50% stop straight away going to reduce those. And dense is again active with a ReLU activation. What is ReLU? Rectified linear unit, making the values in the category from 0 to 1. If something is minus, will be removed, converted to a 0. Apply in batch normalization on this activation also. Pre and post both times we are doing that. Before activation normalization, after activation the normalization. Again a dropout, then again a dense. Final dense is the final outcome layer, output layer with 10 different classes of objects. And at that time, we are using softmax, not using sigmoid because we don't have two classes. Okay. Compiling the optimizer as per what we have defined earlier, loss and metrics, and then checking the model fitness again. So what is the model? Build dropout batch norm model, which we have defined here as a user defined function. We have created that. So now we can call it out. Once we call it, dot fit is used to train it. And again, check the accuracy. And what was the previous accuracy? I am sorry, it didn't seem that. It's very poor, right? 47, 46. Don't make sense. So accuracy is improving and loss is decreasing. So you don't actually see what are the normalized values, right? We are simply implementing layers and getting those outputs. If you want to see them, try to build the same with NumPy kind of a package. Get all those values, for every layer. That is a very much detailed one because we have to deal with n number of neurons. The sparse matrix and all looks very weird in that case. Nothing is improved here. I see it's again 37%. Loss is 1.75 units. For validation, it is 35%. Right? So now there is slightly overfitting. You can see 37 versus 35, but there is no improvement in the overall performance of the model itself, right? There is conversion also very poor happening in the end, but with huge losses. What next we try to do now is let's have drop connect and layer norm as well. Layer norm is normalizing the entire layer itself. Which layer? You can choose any layer, okay? And drop connect is what? Applying a masking on weights of the neurons, not neurons, okay? So certain weights can be captured, can be reduced or can be ignored, sorry. So how do we define drop connect? Drop connect is implemented on a dense layer, any layer of your choice. You define your class as with self units and all those kind of arguments. Rate is 30% drop connect. Then what we do is apply this rate to every particular item of the layer. So self is attached, self is coming from OOPS programming kind of environment. So we are applying rate as whatever object of this class is having, let's say, rate which can be implemented. So it will give the rate for that given object while defining that or while calling that. Then you define create a user defined function for calling the object with self inputs. And then what we are doing is we are also selecting the weights as using the function that, sorry, using the particular the class as self dot kernel. And in that case, what we are doing is we are actually dropping out the weights which could be randomly selected and then dropped out. So weights are attached with respect to the rate. Weights are attached with respect to the rate of dropout, which means that dropping is not done on neurons. It is done on the weights which are attached from the TensorFlow neural network, selecting that function. So dropping the connections. Okay, matrix multiplication will still happen between inputs and weights, and the bias will be added. But the only thing is that there will be masking on 30% weights, which will get reduced randomly. So there is no choice. Again, it is random. What is what is the next step? Once we are building this next model name could be drop connect model, and layer norm is also added. So input is going to be there, your normal input, 3072 kind of inputs. Classification output is this dense, which having 10 different types of classes or objects. That's our output layer. Input layer, output layer defined. Hidden layers are like number one, drop connect layer. Drop connect is implemented on the X layer, a first layer, having 512 neurons. 30% rate is there for dropping them, the weights as suggested by this. and activation function is ReLU applied on input layer. This output becomes the next layer. So applying in the layer normalization on this X layer. Next, again applying a drop connect with different set of neurons, 256. Decrease it. As I mentioned, always try to decrease number of neurons in the next layer to simplify it. So making it 256. Further, you can reduce to the next one, the previous one. Then you can go ahead with 64 and all this. 30% again, and the ReLU is again activated on the same X. Again, doing the layer normalization. Layer normalization is nothing else but now implementing this not on neurons, which are input neurons, but applying this on the output coming from the previous layer. So that is layer normalization, not done on batches also. That batches will be batch normalization. Output is going to be there, and then simply run the model with respect to this function, which is build drop connect layer norm model with training and testing observations, and just run that. Let's see how do we get the results.
Ravi, for this comparison, should we need to give the exact same type of image files?
Same type of
Image files.
to test, right?
Yes.
See, it is only 10 classes, right? So yeah, it can be random also, it should work out. You getting it? Reason being because we already defined those 10 objects, already have those processings. So if any random images are being tested, we should be able to get the results on the top of it. So matching is what we are seeing, right? Accuracy score is the metric, which means that any image you take, apply accuracy check, how much percentage is matching, that's the output. But when you say like end-to-end comparison with respect to these layers, uh, having same images can make you understand those things, give you more insight where the things are going wrong. So from observability perspective, it is good, but not mandatory process. It is good to observe, but nothing like must to have.
Okay, so just to for a much more details on, say example, if I am having a wireframe screen on how the application will be built up. Okay, so that wireframe Figma screens are available. So I am taking that as the X image for base reference, and I am giving a Y image which is which is now the live application which is built. Okay. So I'm trying to see whether in both the images, whether it matches the wherever the
But
wherever the fields
yeah,
are there. So is it matching? I am trying to see. So will that be possible?
yeah. So if that particular object is being trained, then it is possible. If it is something out of the box, which is not included in the pipeline, sorry to say, that's not supervised, right?
Mhm.
You get it? So, for example, I'm dealing with a number of objects and I'm having an output of something out of the box, which is not at all anything from my training data set. So that is not a good practice and supervised mechanism. This is all supervised, right? We are saying classification and all. So it is supervised. When you are dealing with something which is new, coming as a random, that is going to be a new object which not being classified earlier. So obviously it would be a drift for you. You can get the score, but identify it as an outlier. You getting it? So there would be scores, there would be mismatches, but that mismatch you can show the drift. I'll show you one application if I once we wind up this, so that you can understand that drift and all, right? How the new images will be responding to this. Give me a few minutes. So visually I'll show you. Okay. So coming back to this, we see that uh, with layer normalization also, how much is the accuracy? Again the same, right? It's 35, 36. Very cool. Now tell me, if I have these poor accuracies for images which are already there, what could have been gone wrong? Anybody?
Quality of
And
the
refer
image.
to the CNN like structure which we started working in. Convolutional neural network, where I said that the strides, the kind of what we call it, the filters, the max pool, all these things should be in multiple hidden layers. As of now, what we see is we just have a batch normalization and dropouts. In the previous one, we had this thing. In the first one, let me show you where we implemented max pool. Hey, we didn't did that today, right? Yeah. I'm sorry. So I discussed that theoretically. Practically, we have not yet implemented global and max pooling, is it? Right, guys? So what is the answer now? So for this particular images, when we are dealing with them, the layers, if you see, I am handling that with neural network, deep neural network even, but it is not getting improved, which means that we need some more different architecture that is going beyond what is the currently utilized. What is the answer to this? Let's leverage CNN, convolution neural network, which is your week 28 item. So convolution neural network will help us to get those particular absolute values in fully connected layers, and then we can match those images accordingly. In your case, new Figma versus the old Figmas, see what match is there. So at least you can get some percentage kind of, matches. And at the same time, if you see, I have shown you some bounding box. You can also get the location where it is matching, where it is not matching. Right? So that also can be done. These days, I don't know. I mean, people are using those things. Today, it is all large language model. Multimodality is there, so even nobody writes end-to-end algorithms. Is somebody using that still? Are we using agents or are we using algorithms for image classifications in current use cases, if anybody is working? I think we had a discussion last time and most of you mentioned that we don't have any such use case. Is my understanding correct? I can't hear, but is it?
Ravi, actually, we couldn't able to unmute it once. Host allows us to unmute. Then again, if we are muting ourselves, we couldn't able to unmute. That issue where we
I'll
are
learn the
facing.
tricks. I'm sorry, I'm today the entire host and we'll check if it's from my end. But I made you all the co-hosts, right? So I don't know why it's happening after that. Never mind. But
Okay.
you can, yeah, please let me know what you were saying.
No, you are asking question, but people couldn't able to unmute themselves
Oh,
to talk.
sure.
That's the issue.
Okay, maybe those who are joined after we started, right? I think for them it would be right because for others I have made. Silva, are you able to unmute yourselves by yourselves?
He is
Yes, sir.
co-host. He is only the
Yeah,
co-host today.
no worries. Please let me know if it's like next time I'll take care of it. Okay, you can put in the chat. Let me go through the chats. So who's to be unmuted? Sabri also asked. Okay, Sasi already. My bad, guys. I'm so sorry. I didn't go through the chat.
Ravi, I think we have under the options more unmute themselves. If we enable it, I think everyone can unmute on their own convenience, I think.
Please try, guys. That from your side. Otherwise, let me see. On my side, what I can do is let me go to your participant list. Participant list. If I go to Shabri, ask to start video, pin, make host, allowed to multi-pin, put in waiting room. No. It's just I just have one control that is asked to make a co-host. Yeah, sure. Shashi, I am making you co-host. I think we can have multiple, right? Then who is there? Aditya, I'm making you co-host. Confirm. And Sagarika, making you the co-host. Shabri, you know now can speak up, right? Please confirm. Can you unmute yourself?
Yes, it's working now. Thank you.
Yeah. So what I was asking is anybody having any use case wherein we are still using these kind of classifications or even CNNs, or we are using agents?
These kind of classification means what kind of classification you're asking?
I'm sorry.
You ask. Can you please detail your question? So
Okay, my question was simple, like for the current activities, if you are at all dealing with images, are you using agents these days or multimodal model, or you are using algorithms like the machine learning or deep learning?
I
never
would,
been to these things.
but I would definitely recommend not to go with traditional algorithms because it's very costly to maintain and monitor. It's a I mean the evolution of a change we have to inline with agent. I mean
Understood.
LLMs. Yeah.
Yeah, I mean, my take is also that because I don't know. I mean, depends on scale also, like how much you are working on images, but even it's not that costly these days, right? If you have open source, I would prefer a SLM, rather open source one also that one. What I was showing you, why I came here. I wanted to show you something on a rise.ai. Login. Why Atom is coming in, I don't know. Okay, because it's not a domain rise. AI. It's a rise.com. Get started. I agree. I agree.
But Ravi, how we can decide what agent we can use it for our usage?
No, the agent is like anything. Like, for example, I'm not saying that agent's name is specified. Like your task, whatever you want to automate, can be done in a agentic operation. So now you tell me what kind of a task it is. Accordingly, we can discuss.
Okay, so we are into quality team. Okay, so our routine regular activities is based on the user stories or based on the requirements. We will write test cases and we will execute it and we find the defects and we close the move on for next user story. That's how it is. So this is a routine task for us. It depends upon whether it is for web application or it is a mobile application, a desktop application. So testing base will differ.
Got you. So in that case, this is a custom agent, right? Every time you would be working upon.
Yes.
Okay. And what is the platform you leverage or you wish to leverage? Is it
Web
cloud-based?
application will be the most of the applications we used to get.
No, sorry, I didn't get you. It was
Web
fast for me.
application. Web application will be the most of the projects we used to get
Oh, okay.
for banking or healthcare domain, retail domain, insurance.
So
Okay.
Ravi, here R is I mean the data sets, which means it's a vector database data sets or it's raw data.
Wherein on the screen which I was showing or the another one?
In the left side we have the data sets and the experiments.
Oh yeah. It is anything like, see, this is a ML ops, AI ops, and every kind of a observability platform. So you can build your machine learning operations based project, which can be structured. It could be, Gen AI based, or it could be unstructured.
Okay,
What
this
I'm
will
saying,
this can be able to connect with our local LM studio.
Anything. So for example, what you need is, I'll show you. That's your question, right? On integration side, what you can do is you can have your OpenAI integration, you can have your Vertex, you can have all those things. You can have a custom model endpoint. Make sense?
Yeah, I got it. Let me try with Iris. Yeah.
So I was showing you something on an image side, but unfortunately, my package is not having image activation yet. Let me retry, otherwise I'll show you the demonstration with embeddings and all these things. Just a second. Is computer vision. This is productionized and a scalable kind of project, right? You can get it in Azure also, AWS also. You can integrate that. No training. Mhm. Let me see if it is bringing me. Golden data set, experiment, start experimenting. I don't want LLM right now. We'll come to this. No, they have removed the computer vision demo. This is world-class product, by the way, for observability on your large language model, computer vision, anything, machine learning even. I think because they have come out of the partnership with Phoenix, seems like that. Let me see if their GitHub is available. Arise, computer vision, GitHub, Phoenix. Hold on, guys, huh? Just a second. Trying to give you something the best. There's even for MNC, if you're working, you can leverage this like anything. I'll tell you some major problems also, what scalable aspect we are facing. Client evals, Phoenix is there. Let me come from here. See, you can compare agentic framework here. You can also work on Gen agent. You can go some Cron evals. Majorly, they have taken out the piece of computer vision. Seems like that. I'll show you annotations, human feedback. See this one, right? Can you see that MCP tracing between MCP client and server? Everything they are having modernized aspect of image classification. This is what I was looking for. Yeah, image classification. Let me take this directly. The code. No, they don't have a collab direct. This row. Hey, I allowed to download everything. Here is my collab. Don't believe that, that I'm playing these kind of games. This my son is, playing. So all this horror and all. Taking some time, just wait. Almost time it's taking. It's all haunted series, I guess. Okay, this is very good repo. Please get a one account there so you can see all those things, right? Arise AI, you can go ahead. This I'm sharing the link on. There's my chat. You'll be amazed that how fast we can compare, how fast we can observe the performance of any application, be it machine learning, generative AI, agents, whatever you call it. And it has agent on the top of it. For example, if I build a prediction model, you can use an agent which can suggest you where the problem is happening, what can be done to tweak that problem contextually as well, apart from the predictions. It's very big. It's very big, guys. Oh, the speed is poor. Mhm. All right. Meanwhile, let me give a demo on that part. What is that? Uh, exact. Can you see my screen? So here what you can do is, whatever the performance is coming on your model, you can get the evaluations for that agent or application. You can see that PII detection level, hallucination, correctness, all such metrics are already pre-built. What it helps you to do is, for example, if hallucination score is greater than 0.25, okay, it helps you to get that trace. Okay. It helps you to get the P50 latency, like you're aware on latency calculations, correct? If the model is having a latency, it is P50, P50, 95, and all these things, right? From the performance testing side. It helps you to get the cost details, tokens, and all. Latency P99 means 99% times you observe that kind of latency. 50% times you see 8.8 seconds are on an average, being spent as a processing overhead.
So always we should have a less, I mean, in terms of a cost of execution rather than more for each and every user input. Am I right?
As in like latency you're saying or hallucinations?
The value of the latency, would you
It should be,
expect
yeah,
the
less.
best?
It should be less.
Okay.
Today, if I talk about standards, people are expecting that if I'm using a agent, it should have latency around max to max 5 to 10 seconds, right? People are not that patient. Otherwise, there is a concept of streaming where you stream the output, like what ChatGPT does, right? It says, I'm thinking, I'm doing this, I'm doing that, so that people are engaged. So streaming is enabled most of the times when there is a huge latency.
Okay.
You see that, right? The
Yeah, yeah,
streaming
I know
when
that. When I ask the research of something in the my Copilot, it will start writing in the fast manner. Yeah.
this is the way of handling latency these days. Even in one of our mega project, we had to do that
So
so
when
that
it comes to
everybody.
the hallucination score, the 0.25, so it's more like again it's a thumb rule or just you
No,
put
no, 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 no. This is hallucination and all these things. They don't have thumb rules, right? They just can be set as per the benchmarks which you are getting. So maybe you are dealing with something very imaginative. So hallucination will be more. There's something which is scientific. So there should be less hallucination. So like that.
Yeah, since I don't want my model in the RAG, don't want to be creative. Since, in that case, it should be a what is there in the context of the input which I have already feed into that. So can I put my hallucination as 0.05 or something like that?
There is no
My
harm.
system.
There is no harm in putting, but ultimately it is up to the subjectivity which you're getting. And actually, when you apply RAG and all, there is nothing like 25%, 30%. It is relevant or not relevant. It's like that. You get my point. So there is something
Okay.
known as ragas. I don't know if they have ragas here. They don't have, right? So ragas you can check. Ragas will be useful if you are building on a top of a knowledge base. So ragas is somewhat that kind of a thing. They score on RAG application.
Okay.
Yeah. I'll discuss. There are a lot of metrics. I am working on around 27 plus, right? To be honest, on one project where they're into different categories. So I'll share those metrics KPIs
Yeah.
also once we go.
Yeah. I agree. We don't want to deviate. Please go ahead with the Aris, what your
Sure.
hallucination one you are doing. Yeah.
Sure. And meanwhile, I think it's being downloaded also. So let me quickly extract that first so I can demonstrate on image also. And parallelly, I'll show you the agentic also. But now I think you are feeling up to date, right? Nothing is there which you feel that we are out of the date workarounds, right?
Yeah, yeah, I
Parallelly
agree.
proceeding both the things, yeah. So syllabus is also important because we see how we have evolved, right, to that level. At the same time, parallelly, we see how fastidiously what kind of challenges currently we are facing and can drop out. You're saying something, sir.
Yes, Ravi, it's more important in my organization. Next level, if I talk, it will go to that data science. So, data science, I mean, they have their own kingdom. If we want to penetrate, I mean, how we have to understand their system and the way and all how they are operating and where I can add a value to them. So, like, obviously, yes, a history of evolution is very much important when we are going to talk with a higher level of leadership. Yeah.
Mm, understood.
So Ravi, you are downloading the code directly from GitHub and
Yeah,
you are
yeah.
running that in Collab, right?
Yeah. This, if you get this account now, the Arise account, there is no harm. It doesn't charge you anything. For one model, it is almost free. For second model, it will ask $100 something. I don't know if they increased or decreased the price. So it's good to observe any agent or model which you work out. Same as in Azure also. You can implement that in Azure or AWS. So this dashboard you get almost there. I'll show you the beautiful aspects there. Like you can get hold of. You remember we discussed unsupervised learning and all, right? So when you go to this embeddings, you can for a given trace, like you can select that time span from where you want that observability, and you will get all the deviations amongst this output coming in from RAG or agent in this 3D plot. And what this 3D plot does is it is showing us the different clusters of output coming from same agent for different prompts. Okay. So let's say I select these particular, outliers. Okay. The moment I see, I can see what are the deviations, why this output is having that kind of a cluster score, right? More deviated. And on the top of it, there is a mechanism by which you can even attach metric on the top of it. Okay. So those metrics can also be added. So here you can see I have not attached any metric. You can see that evaluation also for the same observations. It's very, very okay. Hallucination score is 0. Can you see this? One I have applied, right? Side. So randomly I can go to anything, any observation of my choice. Basis that outliers, right? So which I want to fix. Okay, this is cool. This doesn't make any sense, right? If I go and fine tune it. What is correctness? Question answer correctness. It's good. It's 100% accurate. What I was looking for. Like that, you can use this platform. But now I'm using it for images. Okay. Let me show you. Some more dumps. That's good. If I go ahead further, let me see if I can launch Phoenix directly. I'll explain this, right? Just I'm first of all connecting, so we don't waste too much time. All right.
Sir, how about break, sir?
Yeah, I mean, after the exercise, can we take a break? So the session will expire, then I can't interact, right? We'll have to rerun. So after this, we can break. I'm
Sure,
showing
sir.
you for this image thing. You can go to the next level. You can use Phoenix kind of applications. The dump I have already given the link. Just use any tutorial on image classification. You will see what today we can do with those. This is run. This is run. Where is my launch pad? Oh, sorry. It's still working, right? Just few seconds more, guys. Okay, I tell you, for this image, what I'll be able to do there on this arises, I can even check the drifts of images, where the images are classified correctly, where it is misclassified, what is the score, blah, blah, blah. I can select those cluster-based image sections. This is the beauty of this platform. Explore, UMap. So when you say cluster 1, cluster 2, cluster 3, different colors, these are there. What are the scores? These are nothing else but any metric which you are choosing to evaluate your performance of this model will be devising a cluster directly. And then you can select those observations and troubleshoot what is the problem in what images the problem is. See, right now we can handle CNN, we can work out. After CNN, what? This goes to production. In production, what? In production, we need to get some automated alerts. In production, we need to see where the problems are coming in, right? When users are using it. So from production perspective, I'm demonstrating it.
So end-to-end traceability is there.
Yeah, end to end, whatever you want. Even you want to add something, I can help. You want to attach an agent on the top of it, we can do that. You want the agent to even fine tune its performance automatically? Yes, we can do that.
Wow.
You're getting it. So it's complete data science agent, right? Which we can work out. The only problem is I have to see where I'm stuck on this launch pad. Session is already there. Then, oh, sorry, this is, okay, this is the session itself, okay. Okay, it's working, guys. Can you see that? Entire app which I was showing is now in purple app. Where I want to show you something is if I can get that image embedding. Generate. Are you clear, guys? I mean, what we are experimenting, please confirm, everybody.
Page plus.
Please connect the dots. We have discussed deep feed forward neural network, right? After that, what I did is, oh, I was scared. So after that, what I did is, I created an application which can help me to trace those drifts. So let me see. If I select this, I get the observability on what happened with that image with this app. More you attach the values and all these things, you get better clarity. As of now, there is no associated dimension attached or values attached. So you need to keep that metric up. So you can handle that, GitHub package and see what all things you want to add in that drift check. Is it clear?
So you mean to say I can add images on my own and then make it learn. Then after that I can do this evaluation.
Exactly. Seeing if I can, some more settings I have to use, maybe some